Hi, and thanks for watching another instructional video for CSCI 1300. In this video, we will cover how to understand common errors in C++ and how to go about fixing them in your code. The first common error that we will cover is what happens when integer division occurs in C++ and how that can be a problem. Imagine in this example that you have three integers variables called s1, s2, and s3, which comprise the top half of some expression, or the numerator of some expression, that will be divided by 3 and then stored into a variable called average, which is declared as a double. Since s1, s2, and s3 are all integers, our numerator will be an integer, and our denominator, since it is 3, will also be an integer, which means that we are dividing one integer by another and storing an integer into a double as a result. In order to fix this, to get a correct double stored into average, what we can do is we can change either the numerator or the denominator of our operation to a double to fix this problem. We can either typecast s1 plus s2 plus s3 by using parentheses double as the data type listed before s1 plus s2 plus s3 in our code, or we could use 3.0 instead of 3 when we divide our expression. Either one is valid and would be able to give us a double in average instead of an integer. The next common problem that comes up in C++ a lot when beginning to code has to do with unbalanced parentheses. A lot of times, students have trouble keeping track of parentheses or losing parentheses along the way when they are copying and editing code. A good rule of thumb when trying to figure out if you are missing a parentheses is to count inwards from left to right in your expression. So if you look here at the bottom, you can see here that if we count 1 here, we have started one parentheses block. We now count in, and we're now 2 parentheses in. We then look at the next one and subtract on our way out now because we realize that this has completed an inner expression. So we go back to 1 parentheses, then back to 0, and we realize that this parenthesis should link to the original one, and that we have an additional one hanging off at the end. So we count -1 here. And we have an additional one that is not being closed at the end. So we can tell that right here, before we do our division, there's an extra parentheses that we could shift over and put in the denominator to finish out our expression correctly. Spaces in expressions really help with reading and determining if you have problems with your parentheses. It is a lot easier to keep track of your parentheses if you space everything out, because that way you can tell where your parentheses start and end. And it's a lot harder for you to look at a series of parentheses, one next to the other, and determine what is linked to what. So if you leave a space between each one of your parentheses arguments, it helps to visualize where one piece is residing within another piece. So if you have an expression that resides within another expression in parentheses, this really helps with determining which one comes inside and which one is encapsulating the other. Another problem that comes out fairly commonly in C++ is forgetting to include header files when you're trying to perform operations with arithmetic. For instance, in this example, say we're trying to include the absolute function. We want to use absolute values. Well, absolute value can be found both in the math library and in the cstdlib library. If you want to learn more about libraries, you can check these out by doing a Google search for c++.com, which is a great resource for understanding how to include header files and what they do. Combining assignment and arithmetic operators is also something that can be extremely useful and can help you understand the operations of your code and write more efficient code in general the more you get into coding. Imagine that you want a total to be added to, so summed up. We want to sum up a series of things into total, and that means that we're going to take the contents of total and modify it by some other things over and over again. Well, we can do that through addition, we can do it through multiplication, and we can do it through subtraction. So in an additional operator, instead of saying that total is equal to total plus some additional variables like cans, time, can, volume, you can sum this up using a combined statement by saying total plus equals cans times volume, saving yourself a bit of code, a little bit of writing. Similarly, if you wanted to multiply by 2 and sum the results into total, you could do the same thing. So this is saying that total times equal 2 is the same way as saying that total is equal to itself times 2. Many programmers find this to be a convenient shortcut, and if you like it, go ahead and use it in your own code. For simplicity, we won't use it in the book though, because it's easier for you to understand basic operations at first before moving on to the syntax. That's all for now. Thanks, and happy coding.